Welcome back to this channel with exercises for professional actuarial examinations. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer financial support, tax-deductible donation to support our actuarial students, please go to smarturl.it/help-ISU-actuary. Here is a problem for Exam FM on financial mathematics. You are the investment actuary of the exciting life insurance company. Your company must make payments of $1 million in 1 year and $2 million in 2 years. There are 2 bonds available to invest in. $1 million par value, paying exactly $1 million in a year from now. 1 year risk-free zero coupon bond with yield to maturity of 4%, and $1 million par value and $1 million redemption value as well, 2-year risk-free annual coupon bond with coupons of 5%, currently trading at the yield to maturity of 4.4%. Calculate the percentage allocation in terms of price, so present value of bonds cash flows, to the 1-year bond in the portfolio of assets constructed to cash flow match the liabilities. So this is a problem about a strategy of cash flow matching, a dedication, where you buy investments that produce exactly the same cash flows as your liabilities. The cash flows of assets match the cash flows of liabilities. That's the key idea in it. Okay, and these are the cash flows required by the liabilities. $1 million at time 1, a year from now, and $2 million 2 years from now. And these are the cash flows produced by the 1-year zero coupon bond. There's only one payment of $1 million 1 year from now. And these are the cash flows produced by the 2-year coupon bond. It pays $50,000 coupon at time 1, a year from now, and it pays again a $50,000 coupon plus $1 million repayment of principal at time 2, for a total of $1 million and $50,000. Since the only the 2-year bond produces a cash flow at time 2, although in the amount of $1 million, $50,000 instead of $2 million desired, we need to construct a payment to pay that $2 million desired out of the $1,050,000, and a unit of that bond is $1 million par value. So how many units do we need to have to pay what is needed, which is which is 2 million instead of $1,050,000? Well, 2 million divided by $1,050,000. That's how many units. Each unit has maturity par value of $1 million, so we have 2 million divided by $1,050,000 units times $1 million, and that ends up being 1,904,761.90 in terms of maturity par value of the 2-year bond that must be purchased. That amount of 2-year bond will produce this 1,904 and so on divided by $1 million times 50,000, because it's 50,000 per each million of face value that coupon payment is, or 5% of the amount that we purchase of the par value. So it's 95,238.10 cash flow or coupon at time 1, and the rest must be provided by the 1-year zero coupon bond at time 1. The present value of the 2-year bond allocated to the asset portfolio is, therefore, this coupon amount, which is 95,238.10 paid as a 2-year annuity, plus the present value, and the calculation is at 4.4% because that's the yield of the bond, plus present value of the redemption value, also at the yield of that bond. So this is just the regular franc formula calculation of the price of a bond. And that represents a present value of 1,926,194.36. And the present value of the 1-year bond in the portfolio is the amount needed, which is 904,761.90, paid at time 1, so we need to bring it to time 0 for the current price, discounted at the yield applicable to that bond, which is 4%, and we get 869,963.37. Well, the question was, what portion of the present value of the portfolio is then allocated to the 1-year zero coupon bond? Well, that's the present value of that bond divided by the sum of the two present values. And that ratio is approximately 31.11%, which is answer B. Please remember that this is copyrighted material. All rights are reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on the test.